Hey guys, haven't recorded the LeetCode problem in a while, so I'm gonna do one today. Hope everyone's doing well. Just once in a while, I'll try to do one. Today's problem is 2918. Minimum equals sum of two arrays after replacing zeros. Okay, you are given two arrays, nums1 and nums2, consisting of positive integers. You have to replace all the zeros in both arrays with strictly positive integers such that the sum of elements of both arrays become equal. Return the minimum equal sum you can obtain, or -1 if it is impossible. I kind of understand it, but let me just run through this example. So example 1, we're going to be given nums1 and nums2. We can replace the zeros in the following way. Replace two zeros in nums1, which are right here. We're going to change this to 3, 2, 2 and 4. 2, 1, 4. 3, 2, 2, 1, 4. Yeah, that's the third thing. And then we can replace 6, 5, 0 with 6, 5, 1. So 6, 5, 1 is 6. The sum of this is 12. And the sum of this is 7, 8, 9, 10, 11, 12, right? So they have equal sum, and I guess it's the minimum, right? So when we replace a 0 right here, we have to replace it with a strictly positive integer. And I guess like in a greedy way, we always want to try to replace it with a 1, right? Because if we want a minimum sum, we should only be replacing with 1. So why would... I feel like that would be a very easy problem, right? Because like, okay, so there are some things we need to consider, like for example 2, when the sum of one of the arrays is like 5, but the sum of the other array is 4, but it has two missing ones. So the minimum, maybe we could have like a minimum sum, and we could keep track of that's, we need it to be at least that much. But okay, sorry. But I think it would be good to have like a nums1 like 0 count how many zeros there are. Nums2 0 count. So and the lengths are different. So n1 is the length of nums1, n2 is the length of nums2, for I in range n1, and then we do for I in range n2. If... oh, actually, we don't have to do by index. We could just do for number in nums1, if num is equal to 0, then nums1 0 count plus equal to 1. Right, so we're just kind of counting it. And then for num in nums2, if num is same thing is equal to 0, nums2 0 count plus equal to 1. So at this point we'll have all of them. And then I guess we could also do n1 sum is the sum of n1, and n2 sum is the sum of n2. Okay, so okay. Just just saying like n1 sum is going to be the sum of this, but then we want to plus those minimum things that we changed to a 1, right? So plus nums1, 0, count. And what would that give us? That would give us 3, 4, 5, 6, 7, 8. That would give us 8. That's the min of nums1. That's the minimum that nums1 can be. And then for the min of nums2, that's n2 sum plus nums2, 0, count, right? Because then that would be 6 plus 5, which is 11, plus there was 1, 0, so that would be 12. So the max of the min nums1, min nums2 is what we need to return. But before we do that, we need to consider what happens if it's impossible. So what does it mean to be impossible? So if our minimum nums is 5, oh, I see. I see. It's a little bit more involved. There's just like a special case that I'm having a hard time considering. Wait, so the minimum of nums2 on this one would be 5, right? So the min nums2 would be 5, and then the min of nums1 would be 1, 2, 3, 4, 5, 6. We need to take the larger one, which is going to be this. We need to take the larger one. Say like if min nums1 is greater than min nums2, else, so we have to do both cases, and this is implicitly saying that, oh actually, else if min nums2 is greater than min nums1. So if min nums1 is greater than min nums2, we need to have at least if nums2, 0, count is like equal to 0, like if there's not enough, then we need to return -1. It's impossible. Same with here, right? Like if the min num of 2 is greater than min nums of 1, that means we're expecting our nums1 to have at least 1 0 in it, right? But if that's not the case, if nums1, 0 count is equal to 0, then we just return -1. So I think that covers the edge case. Otherwise, we return the max of those. Let's go ahead and run this. Oh yeah, sum of n1. It's not n1, it's nums1 and nums2. Nums1, nums2. Nice, okay. Okay, cool. Not that bad. A little bit, it could get like a little bit confusing at this stage right here. It just took me like a second to really think about it. But I think it's pretty easy because we can make up any number we want, right? So if, like I said, like if let's just take this case for example, where min's num of 2 is 5 and min num of 1 is 6, so it would go into this one, right? That means we want like nums2 to replace one of the zeros to become 1, right? But what if there's not enough zeros to do that? Which means that num's 2 0 count is 0, which in this case it is 0. Then it's not possible, right? We'll return -1. And the same could be the other way around if this was a 6 and this was a 5. Yeah, not that bad of a problem. Let's analyze the runtime. So this is just, it runs in O of n, whatever is greater, O of n. The time is O of n, where n is the max of the length of nums1, nums2, len of nums2, whichever is greater. Sum is the same, it's just O of n. Yeah, that's it. And then space, 0 count. No, that's just a variable. So it's just a constant space, O1 space. And that's about it. Hope you guys enjoyed this video and thanks for watching.